All right, and I'm going to share out a link real quick too here, just right before we get going, because people ask where the recording will be posted, and it will be posted on our YouTube channel there. But I will also email it out to you afterwards. So this is an Intro to Computer Vision workshop. We're going to build our own object detector and a data set for that, which again, the data set portion is super important. And again, for anyone who just came in, actually real quick before we get going, I will share this one more time because a lot of people did just join. So the only important thing is is the last link there to sign up for the account where we're going to use the data annotation tool. And someone just asked about the Slack channel. The Slack channel is that top link in the chat there. And it's a great way to stay connected and ask me any questions after the workshop as well. All right, so let's get going. We're going to build our own object detector and data set for that, and kind of all the key concepts you're going to learn along the way. So when you go and do this on your own problem, create your own solution with computer vision, you'll kind of know all the steps to take, or at least get started. Hit record. I already have that going. So setup again. Just for anyone who came in, I just shared this. I'll share it one more time anyway, because I know people keep joining as I keep going. You're just going to want to sign up to the data annotation platform. You'll put in your email, type in a password, and then you'll get a verification email. You just want to hit verify in that email, and then you'll be able to use the platform. And then you will need a Google account because we're going to use a tool called Google Colab. That's where we're going to run our code. It's going to make it really easy for anyone, even if you've never programmed before. And you can just use your Google account for that. And then a modern web browser, just like Chrome, anything like that. It should probably work on any browsers you're using right now. So just a kind of recap what this workshop is. Hopefully it's going to be a super friendly introduction to computer vision. It's kind of designed for no previous experience expected, but knowing some Python will be helpful when we get to the code. But if you haven't programmed before, or you haven't programmed with Python, don't be scared. I'm going to walk through what's happening as we go, and you'll still be able to run everything and leave the end of the workshop with a trained model that will be run on a video and like write out a cool output. So again, if you've never programmed before, I still encourage you to stick around. Hopefully it will not be very painful at all. And then we're going to cover some applications and basic intuition. So that's really just kind of the short slide portion of this workshop. Just so we know like why you need to label your data and a few things before we get into training. And then we're going to go into how to label your data. It's going to be kind of hands-on. You can watch me or try on your own images. I'll give you some sample images that you can try on too. We'll go through different ways of labeling for object detection and instance segmentation, and how to speed up those processes with some awesome AI-powered kind of tools. And then we're going to jump into code. So we're going to learn how to export our labels. Then we're going to jump into code. Again, it's going to be in a Colab notebook. And then we're going to train a model. And then I will also give you a link that you can fill out to get like a certificate of completion. And then just keep in mind, this is like an intro, and we're actually doing something really complex, creating a object detection model. But again, I think it's going to be in a way where no matter your experience, you'll be able to follow along, and it's going to be awesome. Just keep in mind that you can't learn everything in 2 hours. So part of this may feel fast-paced or challenging. That's totally okay. You'll learn a lot by sticking through it. And then, the most important thing is to keep learning after this workshop and tackle your own problem. And I'll point you to some resources afterwards as well. And like I said, I'll also be hanging around so you can ask me any follow-up questions. A tiny bit about me. My name is Sage Elliott. I'm a machine learning developer evangelist at Plainsight AI. We do really cool stuff in machine learning, computer vision, IoT, across a whole bunch of different industries. And then we're also creating tools to make it easier for everyone. So one of the tools you're going to see tonight is that data annotation platform. And for about the last decade, I've worked in either software or hardware with mostly startups and a couple agencies around Seattle and also Central Florida. And I love making things with technology. And also, I just added this in here because I tend to kind of talk fast when I'm presenting, so I'm sorry about that. I can try to slow down sometimes, but then I always realize I start talking fast again. But you can stay connected to me at sageelliott2ls2ts.com, and you can find me at most places at Sage Codes, or connect with me on LinkedIn. Again, you can just search for Sage Elliott, and I should pop up. All right, so about you. Normally, when doing like in-person events, I always love going around the room, if it's a small enough room or a small enough crowd, and have people introduce themselves. But since there's close to like 100 people in here right now, you could communicate in the chat where you're watching this from. It's always really cool seeing the reach. And then also, I know some people already put this in the chat, but why are you interested in computer vision? It's always really cool to kind of see like, where are people watching from and why are you here? So feel free to throw it in the chat. And again, you can hit that drop down to go to everyone, not just to me. So it said Washington, DC, New Jersey, Arizona, Philippines. Awesome. So it's always so cool because I did so many workshops in Seattle at previous companies in-person events. And it's always really cool doing online now because just seeing the reach. Like I see someone's from Egypt, like that's so cool that you're watching this from there. I see quite a few Seattle people. Nice to see you here. I see someone else is in Florida. Like I was saying, that's where I was before I moved over here. Boston, several Boston people. Philly, moving to Seattle. Awesome. Well, welcome. Feel free to reach out to me on LinkedIn, Montreal. And then I'm going to share this link. So, I miss staying connected with people and like learning what other people are working on. So I have that Slack channel. I shared the link previously, but here is the link again. It's a growing Slack channel where you can stay connected with everyone here if they join, and then also with me. So if you have any questions after this workshop, post it in there. And you can ping me directly, but I always encourage people to post in general or one of the other channels. That way someone else could be able to help you if I don't get to, or if I don't get to fast enough, someone else could pop in there. So join that Slack channel, ask questions in there. There's also a intro channel. So if you kind of just want to introduce yourself, talk about what you're working on, what you're learning, how you could help someone, there's a channel for that too. So awesome to have everyone here. So cool to see where everyone's watching from. And hopefully I will see some of you guys in the Slack channel or on LinkedIn later as well. So setup, repeat, just for anyone who just joined in. The only thing you'll probably need to do is make an account there, put your email in, put a password in, verify your email, and you should be good to go. Otherwise, it's just having a Google account and a modern web browser. All right, so what is computer vision? It's a very big field, but I would kind of boil it down to how computers gain understanding from images or videos. And there's other types of data as well that could kind of be converted into an image or a video. So you've probably seen audio visualization before, like from a song playing. You could think of that as being as audio being converted into visual data, and then you can actually use computer vision architectures on that same data. And there's some really good results with it generally. So there's also like LiDAR data, which is kind of a 3D representation of it, and that could be considered computer vision as well. But in general, like if you're just getting started, I like to think of it just understanding, data from images or video. So here's a little example. This is using instant segmentation and object detection. We'll talk about the differences of those things deeper in a few minutes. But for now, you can see it's drawing a rectangle around where this truck is, where all the trucks are. And then it's actually painting the pixels of very precisely where it thinks that like the truck is, not just the location with this rectangle, but it thinks these pixels precisely belong to a truck, and that's why they're being colored in there. And then you can see the one that's moving, it's green, and the other ones are red. So this is kind of another layer after you do object detection, where you can count, like, is this object moving or not? Has it moved in a certain amount of frames? And then you could classify it as moving or not. And so you can see that this is localizing where these objects are and kind of classifying them. So it's a form of object detection. So one reason why I really love computer vision too is just there's so many really, really cool applications of it today. Like right now in the field, you can go look at a whole bunch of different companies doing really cool things. So here's some that use computer vision. Some of these you may have heard of, and then hopefully some of these you haven't, or maybe they're fields you haven't really thought about that might be using computer vision. So in Seattle, we have a very small local company, you might not have heard of it, called Amazon. It's a Seattle native company. So again, everyone might not have heard of it. Obviously, I'm joking, one of the biggest companies in the world right now. But they have a store that actually is mostly in Seattle. I think it's in other states now. There might be some outside of the states, but called Amazon Go. Has anyone gone to an Amazon Go yet? If you haven't been, it's a store that is all computer vision based. So you can actually just, you scan a QR code, or some of the stores now, I think you can scan your palm and it'll let you in. And then it kind of tracks you as you go throughout the store. And then you pick up items. It sees what items you picked up with cameras. And if you look up, there's just arrays of cameras and, like, I assume some sort of GPU processing unit up there. And then they assign the value of the item with you. And then you walk out of the store. And the first time you go, it feels like you're stealing because you don't check out. You just pick up items and then you walk out. And so when they first opened it, it was funny because they had greeters by the door and they're like, no, it's okay, come on out, you can go out. And now I go to them quite a bit because they're around where I live. And sometimes I'm afraid I'm going to go to another store and then just walk out because I'm getting so used to the just walk out technology is what they call it. And then also, they actually just added that technology to our new arena in Seattle, the Climate Pledge Arena. It actually has the same thing. It's like you can go into an Amazon Go, but it's another like restaurant, and you can walk in and pick up food and leave. It's very interesting. And I think we're going to see just more of this going into a whole bunch of different stores. It's really interesting if you haven't seen it yet. And then they're also building delivery robots, right? Robots that can navigate sidewalks and deliver packages, self-driving cars. They bought a company recently, a year or two ago, called Zoox. Product listings, a lot of images get uploaded to Amazon. They need to analyze those images, make sure nothing bad is in them or that it might match the product. Or I've heard there's maybe some stuff around like counterfeit products in there too, which is interesting. Google, a lot of people have used Google before. You might have used Google Photos. You can search for a dog and it can bring up all the dogs in your photos. YouTube content filtering, so many like gigabytes get uploaded like every second to YouTube. They need to kind of analyze that, and they use it for like copyright striking and all these different things, right? Self-driving cars, Tesla, self-driving cars. Notably, they're one of the self-driving cars companies that's using like only cameras to do self-driving, which is interesting. A lot of the other companies use like LiDAR or radar as well. Facebook, you might have uploaded a photo and you get like your face tagged or a friend's face tagged. And then we have these other fields, right? Like these are all kind of big tech companies that we've probably all heard of or seen in some way using machine learning or computer vision. But there's a lot of fields like agriculture where you can do like crop and animal monitoring, which is actually a field that we work a lot in at Plainsight. Construction, site monitoring, making sure that everyone's being safe. They're not in zones they shouldn't be in. They're wearing all the correct PPE. I've seen a company working on a self-driving tractor, which I thought was really cool. Manufacturing. This is actually how I got into computer vision. And there was an article I shared earlier about kind of detecting bad product as it was going through the manufacturing process, doing the quality assurance with computer vision. That's actually what got me into it in the first place. Measuring throughput, oil and gas, again, a lot of safety, leak detection, healthcare, X-ray diagnostics, MRI scans, medicine research. And this is by no means all the applications. Like, put in the chat right now if you have one that you're interested in that I didn't mention. Again, there's a whole bunch of them, like drones. There's a lot of cool stuff you can do with drones. Someone mentioned detecting fires. Does anyone have any other kind of applications or companies or something that they're really interested in that I didn't mention? Or anything really cool they've seen recently? I saw a startup here recently that it's called Carbon Robotics, and they're creating a robot that can drive around on a farm and then detect weeds and then shoot it with lasers. So instead of using weed killer or anything, it actually just drives around and shoots lasers at weeds, which is really cool. Someone said creating NFTs. I'll talk very briefly about GANs in a little bit. I've actually done a lot of stuff with GANs, and that was something I was like interested in, just not even just for the NFT, but creating kind of art or original images with deep learning is really, really cool. Someone said biometrics, nuclear power plant monitoring. That sounds cool. What kind of monitoring? Someone said quality control. Yeah, quality control is awesome. And again, that was how I got into it. There's so many really cool applications and different ways you can do things with computer vision for quality control. And it might not sound like the coolest thing ever, but it's a big problem, right? Like catching all these things that can be really hard as a human, and having computer vision help you or do it even better is really cool. Someone said fashion clothing. That sounds cool. Is that like creating fashion clothing or like looking at different fashion? There's so many cool different applications with it. Someone said gaming. That's a really interesting one. I've seen that was a big problem. I forget what game it was, but they had a big problem with people using computer vision to like detect movement and shoot faster. I forget what game it was, but that was an interesting problem people were having. All right, awesome. Thank you for sharing your applications, and feel free to keep sharing them. I'm just going to go ahead and keep moving through the slides so we can get to the hands-on portion pretty fast. So I just want to mention computer vision and deep learning. Computer vision isn't strictly always tied to deep learning, right? There's a lot of different I don't know if I should call it classical, but classical computer vision where you're not using deep learning. And that could be something like, most of us have seen a green screen application, right? Where you could be in front of a green screen and then paste a different background behind you. A lot of that doesn't necessarily use deep learning, or at least it didn't. Maybe it does now to make it even better to segment the human out. But traditionally, that was just really looking at an image and then replacing all the green pixels with another image or a different color. And you didn't really need deep learning for that. But most of the things you see nowadays, all those really cool applications like tracking, people recognizing different animals and stuff like that, most of that's using deep learning kind of behind the scenes. But I just wanted to mention that. And then why we need deep learning in this case, and this kind of goes for most supervised machine learning algorithms. Just imagine we have like a function. You could think of a programming function, a mathematical function, or just something that we're going to adjust and learn. And that's our function, the thing that can learn. And we're going to pass in our training data to that function. And so for this example, think if we were training a classic cat and dog detector, we would feed this function images of cats and dogs, and we would have labels assigned to those saying, hey, this is an image of a dog, and kind of figure out what features make up a dog. Now look at an image of a cat. Now figure out what features make up a cat and why it's different than a dog. So you would feed all these images in, could be hundreds or thousands of images, and it could look at them like hundreds or thousands of times. And after it's looked at them a whole bunch of different times, hopefully it had learned what makes up the differences between a dog and a cat. And then we could feed it a new piece of data that's never seen before. So an image of a dog it's never seen, it wasn't part of the training data set. And then it would get a prediction or give a prediction on that image. So it would say, well, I think that was a dog on a data it's never seen before, because it was able to look at like thousands of other pictures and kind of make up those, what makes up a dog or a cat. And it's a really hard problem. And that's why we need kind of deep learning behind the scenes. Because if you were kind of thinking of, like, let's say you were going to program a whole bunch of if statements in code, it would be really hard to come up with what makes up a dog or a cat. You could say like, well, first you'd have to find, where they are, and then kind of look at the ears. The ears are a different shape, like maybe the nose is a different shape. And there's so much variations of different cats and dogs, all the different dog breeds. It's a really, really hard problem. But it turns out if you use deep learning and you just give it a whole bunch of data, it can figure out those rules for itself. So you can kind of think of deep learning, you're giving it data and the answers, and it's kind of coming up with the rules, right? And then in this case, right, like what makes up a dog, what makes up a cat, and then it can look at a new piece of data it's never seen before and hopefully perform very well on it. So a lot of other kind of getting started tutorials will go much deeper into deep learning. I'm going to share a couple links here that are cool to look at. There's a really good visualizer for visualizing a deep learning neural network. And there's also a visualizer for convolutional neural network. And convolutional neural networks are usually used for computer vision. And that's what is going to be working behind the scenes with our object detector today. We're not going to go too in depth on these today, because really all you need to know is why we need to label a data set. It's to learn from it, and then it's going to make a prediction. And then we'll get into the code of how to actually pull in a model, feed it that training data. Just a quick note on transfer learning. So with most popular deep learning frameworks like PyTorch and TensorFlow, you can load in pre-trained weights into your network. So these have been trained like quite extensively on a whole bunch of objects and animals. Often there's a COCO data set, which has like 81 classes in it. And it can recognize these things pretty well, but not perfectly in all situations. But it might have like a cup or a bird or a person. And it turns out if we take these pre-trained weights, even if the object we're training for isn't in kind of those classes yet, if we take that and then train it on a new object, like let's say geese are not in there, for instance, that's where we're going to train tonight. We're going to feed it a whole bunch of images of geese, but it already kind of knows things about the world. It knows how to construct different corners, make up different shapes, and things like that. And so really, you can just think of it as not starting from zero. That's what transfer learning is. We're using weights that have already been trained on other objects. We're taking that, then we're going to feed in our own new data, and it's going to adjust those weights and tweak it for our use case. But without it, it would take so much longer and probably a lot more data to kind of get the accuracy that we're going to get tonight if we didn't have transfer learning. So just a quick note on it. All right, so some types of computer vision. Computer vision is a huge field, so we're going to talk about ones using computer vision deep learning, and then kind of the most common types. So many of these can kind of be combined together in different ways too for various outcomes. Someone asked, will the session be recorded? Yep, it's being recorded and it'll be uploaded to our YouTube channel, and I'll email out a link to everyone as well. Any other questions before we get into the different types of deep learning? I know we didn't cover too much yet, but just want to make sure everyone's good. All right, so some of the different types, we have classification. This is like what we talked about in that deep learning example, right? Where we were going to detect dogs and cats. In this case, I trained a network to predict dog breeds, and then I fed it this image and it predicted it was a Labrador Retriever, which does look correct to me. And most tutorials will start here and cover classification really thoroughly. So this is great if you want to see kind of like everything in an image or a specific cropped part of an image, but you kind of run into problems very quickly in a lot of applications because we can detect a dog is here, but if like a little Chihuahua was back here, we wouldn't know that. We would still just get a prediction of like, well, we think it's a Labrador Retriever. We don't know that there's another dog back here. Or that might throw off our prediction. It might predict Chihuahua or something, even though a lab is up front. Or if a cat and a dog was in here, our cat and dog classifier would be really confused. So we quickly run into problems, but it's great to see if something is in an image or not, but we don't know where it is really. And that's where like object detection comes in. So object detection can classify and localize where an object is inside an image or a video. And almost more importantly, maybe is it can do it for multiple objects, right? So not just one. We're not just like saying like, hey, a goose is in this photo, or we think geese is in this photo. We can say a goose is here and a goose is here. So we can actually get a count. And sometimes this is all you even need for your like solution, right? If you were measuring how many people are in a room or how many birds are in your camera feed, and then you want to get a text or some sort of alert, or if someone is walking in an area they shouldn't be, you can do that with object detection. And we're going to make this today and cover how to make your own data set for this. So really powerful right off the bat. And you can also track like where these are in the frame. So you could have like, if this was a hazardous zone that no one should be in, you could kind of like have a line here and then measure when an object that you're tracking goes into that zone and then send an alert. So really cool. You can do a lot of powerful applications with object detection. And then instance segmentation. So some people are asking about this and excited to kind of learn how to do or work more in it. And again, it's kind of similar to object detection. It can detect, it can classify and localize where the objects are, but it can also do, it can also provide estimates of exactly where those pixels are. So here we can see that it's detecting bottles, it's coloring them red, and then it's detecting water, coloring them blue, and not just like the bounding boxes, though, actually precisely where those pixels are. And so in this case, you could do something like a volumetric calculation, seeing like how full these bottles are. When the water level overlaps enough of these red pixels, we know the bottle's going to be full. Or in other applications, like if you were detecting hands, you could do this maybe with feature points as well. But if we were typing on a keyboard and you had like if you're typing on like a virtual keyboard in VR or AR, which I also saw someone mention augmented reality as a cool computer vision application, right? You could detect like precisely more where the fingers and hands are, and then detect what keys those fingers are touching, versus if you're doing object detection on a whole hand, you would maybe just get that bounding box and it wouldn't be as precise. Also, it tends to be that if you train in instance segmentation, you can often squeeze out a more accurate model versus object detection sometimes as well. Because you can think of this architecture is just more precise, right? Like knowing exactly where a bottle is, it's going to be probably hopefully pretty confident about that. And it might be more accurate than an object detection model. But we'll talk a little bit more about why maybe you would choose that versus an object detection model in a bit. We have feature points. Some people were talking about doing applications for reading like facial expressions. Feature points is often used in that field, but also in like whole body pose estimation for people and animals. So in this case, we're detecting poses of people and then changing it when they changing the classification of their pose to a different yoga pose. But this is cool for seeing like where people are, how they're interacting with something. You can also do it on hands. So you can see, again, really precisely on fingers. Like I was saying, you might be able to use this instead of the instance segmentation for typing on a virtual keyboard, or gestures, right? So if you've ever used an augmented reality device like the HoloLens or something like that, you often do a gesture in front of your camera to do an action. That's using computer vision in some capacity and probably the feature points to understand what you're doing with your fingers. We have generative deep learning, GANs, which stands for generative adversarial networks. someone was talking about generating, I think, art with GANs for NFTs. And I did some work on GANs. I have a project here I worked with someone called Michael. It's on his site there, but we basically trained a model to generate original 2D architecture designs. He used to be an architect, and we were like, how can we make this process simpler for the person doing those original sketches before you design? And so we scraped some data, and then we're able to train a pretty cool GAN that could generate those images as well as some interiors. And we didn't use any crazy GANs either. So there's some really cool ones that you can look at that are like really high quality. They create humans that look real, but they never really existed. Really crazy. The generative deep learning space is awesome right now. And then this image on the right, or my right anyway, this is actually when we were creating the original 2D images for architecture. This was in between when it actually didn't quite look like buildings yet. It looked like really cool art. So I saved this image, and I thought this was awesome. So like using generative deep learning for art is just kind of a really cool field too. And so the person talking about it for NFTs, maybe you would do something like this and list this as some sort of original AI art, which I think it looks cool. It looks like space or something. Choosing a model. So there could be many different cases for all these different models and why you might choose them. But if you're just getting started, just really think about what is the problem you're solving and what's the outcome you're looking for. So if you're just counting how many people are in a space, you can use object detection for that. Do you need something more precise where like you need to see the pixel by pixel interaction between objects? Then maybe you need instant segmentation. Are you doing pose estimation or facial features? That's probably feature points. Here's another little example. So you can see this is using the interaction between those pixels of the food and the pixels of the mouse. So to classify it when it's feeding versus not feeding right now. So when it moves away from it and kind of leaves it alone, then you can classify it as not feeding. So before I move on, out of all these ones, besides object detection, what do you find the most interesting? Let's say if we did another workshop and you wanted it on something else, since we're doing object detection tonight, what would you want to see a workshop on? Someone said generative design. So it'd be like the GANs, generative deep learning. I think it'd be kind of cool. Someone said pose estimation, also a good one. A lot of people say GAN, which I get because it's like super interesting. And that'd be really fun because you could leave like with your own original generated art or something would be really cool. Someone said they have a quick question. Feel free to post questions and I will try to answer them when I can if I see it in the chat. Someone asked, can we do live GAN on videos? I'm not sure. Probably. Well, I don't know. You can overlay something on a video. The GANs tend to, the way I've done it anyway, right? Like there's a bit of a process of like, essentially you train two networks. One's the discriminator and one's the generator. One generates the noise, like it starts as noise first, and then you pass it through the discriminator. It kind of says, hey, this doesn't look like the thing you're trying to generate, adjust stuff. And it keeps adjusting. So it actually tends to take a long time to create something that ends up looking like the thing you were trying to do. But there's probably some way of taking kind of a pre-trained GAN that is already at some point and passing in frames of a video and then quickly generating something. That would be interesting. But I haven't seen that. I'm sure someone's done it. Someone said, the question is, would object detection or instant segmentation be better if we're trying to distinguish trash and recycling? It depends. They're very similar. So I would say start with either one, depending on your data, and see how it works. So object detection, well, we'll go through labeling, and maybe that'll help you make a decision as well. So again, there's some trade-offs. I'll talk about it, actually, I think right after this. So I think after this next slide, a little bit of the differences. So with object detection models tend to be a little bit lighter weight than instant segmentation models. So that can also be a factor, like how fast do you need the prediction return? And another factor could be how is it being deployed? So if you're doing it on a smaller edge device, a object detection model, a lighter weight object detection model might work better. So for example, if you're running on a Jetson Nano, you might want to use something like a single shot multi-box edge detection model, which I'll talk about in a second. But in terms of just doing classifying it, either of those should probably work, depending on what your data looks like. But I would imagine both of them would be good. Someone said they think emotion detection has seen some advancements. All right, so I'm going to keep going. If I missed any questions, sorry. But again, feel free to ask them later. So object detection in a gist, you kind of it'll find these, you train network and it's going to find these proposed regions where it thinks there is an object. Then it's going to run kind of a classifier around that region, which is going to be trained during our training process. And then it could calculate kind of the estimation of where that location is. So this link is a great one if you want to dive way deeper into kind of how object detection actually works behind the scenes. Really good little read. But just this is kind of what's going on after we train our network. It's to be like, I think there's a goose around here. It's going to run a classifier and then do some sort of calculations to kind of estimate, pretty precisely, hopefully, where that object is. So some popular object detection methods, a couple of these I talked about already. So single shot multi-box detector, or abbreviated to SSD. It does object detection, so like drawing those rectangles, and it does it usually very fast. They have yellow, you only look once. It does object detection, also tends to be pretty fast. There's so many iterations, especially of yellow that I see coming out, and I can never keep track of which one is like better all the time. But often there's a trade-off between being like more accurate versus being faster. And so like I was saying, sometimes you need to choose something that is going to be a little less accurate, but can run better on some sort of edge device. And then you have Mascaro-CNN, can do object detection, instant segmentation, tends to have very high accuracy, but tends to be a little bit slower than these other ones. And we have this library called Facebook Detectron 2. This is actually what we're going to use today. It's kind of a wrapper around PyTorch, which PyTorch is Facebook's deep learning framework. And I'll just show what's going on in this video. So this is a library that makes it pretty easy for us to train our own models with our own data sets. It can do object detection, like it's showing here. Right, it's drawing around backpack, chair, all these objects up on the counter. It can also do pose estimation. So someone was talking about doing some sort of application with pose estimation. This could be a good library. It also does dense pose, so it actually kind of tries to reconstruct a 3D representation. So you can kind of use this as like, creating a game character or animate a movie or something like that. It kind of has those use cases. And then here, one thing I want to mention real quick is, oops, I went back too far. I'm just going to keep playing it. So notice it shows this instant segmentation, right, where it's drawing like the pixels of where it thinks the table is, where the chairs are. And then it goes into this version of instant segmentation where it draws literally every pixel in the video. And this is cool if you want, some more context of potentially where objects are. So in this case, right, it's detecting a cabinet, a wall, a ceiling, a microwave. So maybe if we were like, well, where are these people at? And you could probably make a good guess that they're in the house, right? Or if you want to see all the interactions between all the different objects and where they're moving. And if this is outside, I would probably say, skyline or sky. And this is the library we're going to use. So it makes it pretty easy for us to kind of take our own data. And then it has pre-trained models, so we can do transfer learning. And you'll see we're going to get in the code a little bit. We're actually going to be able to train a model pretty fast with not a ton of data for object detection. And then real quick, just going to mention the full computer vision lifecycle, and then we're going to get into the hands-on part. So we kind of briefly talked about like data annotation, right, labeling, and we're going to get more into that next. And then we're going to get more into the machine learning and model selection training. So a lot of people will just kind of start and they learn about machine learning, then they might learn about data annotation. But really in the real world, there's often many more steps kind of in this whole computer vision lifecycle. So you have like device management. We talked about deploying to a device. You need something to kind of manage that or also manage sensors. So in computer vision, right, it would be cameras. If it was other forms of machine learning, it could be other types of sensors as well. Or in computer vision, it could be LiDAR. You have data collection. So once you are capturing the data, you kind of need to manage it and create different data sets and often even like keep track of what data sets are what. And like segmenting those clips. That could be web scraping too if you weren't getting it directly from a sensor. Then you have the labeling of that data, the training with that data, and then once you train a model, then you need to deploy it. And so you're learning all these things. You can learn how to train a model, and then you might be like, oh man, now I need to deploy it. This is really hard, and get stuck. And then you often want to repeat. So like I mentioned, for some people that were here a little earlier about how you often kind of want to repeat this whole cycle over and over. Like you want to collect data as you're running on it, and then label that data, or have a machine learning model help you label that data, and then bring that data back into your model and retrain on it. And this is really important for seasonality. So for example, we talked about Amazon Go, right? If you're detecting people walking into your store and you only trained on people in the summer, the people in the summer, they might be wearing tank tops, they might be wearing baseball caps, they might have shorts on. And then the people in the winter, they might have big coats, they might have scarves, they might have really puffy hats, and they would probably look way different than how people look in the summer. And so you have this kind of big drift between what your model was trained on versus the data it's now looking at and trying to like run object detection on, for instance. So you want to capture that new data and then label it, or have the model label it for you that hopefully is accurate enough, and then retrain it. And that will help you kind of avoid this drift between your data. So it can be really important for a lot of things, but seasonality is one big one, right? So if you're even classifying animals in the summer on green grass, and then it snows and those animals are in snow now, it looks way different to your computer vision model. Even if you as a human, maybe it doesn't affect the way you look at it too much, but it'll probably affect a model quite a bit. So we kind of do that all in one platform. We're actually releasing a lot of these steps really, really soon. Today, we're just using the annotation piece of it, and the whole thing isn't available for you just to easily sign up for yet. But if that is something you're interested in for your company or something, feel free to fill out the contact form there. And then also, if you do want to check out, we currently have it on Google Cloud Marketplace, which is cool if you need your own like private instance of kind of that whole computer vision lifecycle. All right, so let's go ahead and get into the data annotation part. And I'll pause for questions, but first I'm gonna share this link. So if you didn't sign up already, this is the point where you probably wanna sign up, and we're gonna walk through how to use this data annotation tool. Again, there's no card or anything required. Sign up with your email, make a password. It'll send you an email, and then you'll wanna click verify in there, and then you'll be able to go into your account on here, and we'll talk about how to use it. And even if you end up using any other tool at some point, a lot of the concepts will go over from here to anything else. So I'm going to open up for questions for a minute while anyone is signing up that didn't sign up yet. So any questions so far? We covered a lot, especially if you've never done computer vision before. I also need a water break, so ask questions. Someone asked, we're going to use Sense tool. Yeah, so this is the tool that we're going to use to do the annotation, or the different annotations. So you can sign up at the link I posted in there. And we'll cover how to label for object detection, which is going to actually be kind of surprisingly easy. And I'm actually going to talk a lot about instant segmentation, because a lot of people use that. Someone said the link takes you to Slack. Is that true? Or is that a different link? This link should take you, I'll share it again. Oh, did I have an old link? I'll share it again. Sorry if I shared the old link. There's a Slack channel though. If people didn't sign up, I'll go grab that real quick too while people are signing up. Slack channel, again, is great if you want to stay connected, ask questions, connect with other people there. And I think I saw another question, so let me catch up real quick in chat too. Someone asked, what are some model examples for instant segmentation? The one I often see the most is like a mask RCNN or faster mask RCNN, which is going to be what we're training today. And then the other one I feel like I see a lot of right now is UNet. Someone asked, what's the story behind SixSkill? So if you weren't here at the beginning, the SixSkill is still in the URL for the product there, but we rebranded to Plainsight. So now the company's name is Plainsight, but you will still see a couple SixSkill links. So sorry if it is confusing. Someone asked, what is my preferred transfer learning model? Most of the time I work in object detection or instance segmentation, and all the networks basically, like all the major frameworks like TensorFlow or PyTorch or Detectron 2, they'll have pre-trained models for it. So a lot of times those models are trained on the COCO dataset, which is one of the largest instance segmentation and object detection datasets. So often I start with a model that's been trained on COCO. Someone asked, is there any implementation of Detectron 2 in TensorFlow and Keras? Not that I know of, but I'm sure there's other high-level kind of libraries people have made that use TensorFlow in the backend. And Detectron 2 is made by Facebook, created by like the AI research team there. And they also maintain and created PyTorch, which is what Detectron 2 uses in the backend. So if you don't know, if you haven't done a lot with it, there's usually two major frameworks, and that's PyTorch and TensorFlow. PyTorch is maintained by Facebook, or it's open source, but I believe they still kind of maintain it. And then TensorFlow and Keras is Google's version. Someone asked, what would I prefer as a beginner, creating the object detection segmentation model from scratch to learn the details, or use transfer learning? Most of the time, I would use transfer learning. Because I mean, like if you're going to use a model for object detection or something like that, you can import those weights into it. And you'll see, so tonight we're gonna use transfer learning, and without it, it would take us a lot longer. But I mean, feel free to go through and like do an implementation yourself from scratch or something to learn. And if you do that, depending on how you do it, you may not be able to use transfer learning. But in a lot of real applications, a lot of people use transfer learning. It was one of those things that made a big change in the industry, because it's like, instead of starting from scratch every time, you can now use transfer learning, throw some data at it, and get good results pretty quickly. All right, so I'm in my labeling tool. I have some projects in here because I've already used it. So I'm going to share one more link. This is if you want to follow along with the exact images that I'm going to use. I'm going to use the one in the object detection and instance segmentation folder. Feel free to just upload your own images though. So what we're going to do is we're going to go through this tool. I'm going to show you how to use it on some sample data here. But feel free to like bring in your own images that you might already have on your computer and kind of experiment. How would you label them for polygons or object detection? And especially if you happen to have like images on your computer of the problem that you think you might want to solve afterwards, that could be a really good learning kind of experiment to do. But otherwise, don't worry about downloading that right now, because if you miss this step right here of downloading those images, you can still complete the workshop. So don't worry about following along exactly here. Really just focus on understanding how to use this tool so you can bring in your own data set after this and create your own computer vision model. So I'm here, I have some objects or projects. It's going to be empty for you probably. And what you want to do to create a new project is just hit new data set. And I'm going to give this a name. I'm just going to call it workshop, but this should be a meaningful name of your project, right? So if you were labeling dogs, it should be dogs, or maybe where those dogs were even gathered, or what kind of labels you're going to be labeling with them. But for this example, I'm just going to call it workshop, and we're just going to go through and look at some samples. And then we go to sources after I hit save down there, and I'm going to add a source. So you can upload your own local files. You can also connect to Amazon S3 and Google Cloud Storage, right? If you're in a enterprise setting, most likely you're storing stuff on S3 or GCS anyway. Just noting too, one cool feature that is out right now for Amazon S3 and Google Cloud that is not there for local files is automatically breaking apart a video. So often you might collect a whole video from a stream or something, and then you want to import that video in to be labeled. And if you have that in the S3 bucket or the Google Cloud Storage, it'll ask you how many frames per second you want to break it down to. Right now for local files, it doesn't happen automatically. But I'm going to choose local file. I'm going to hit choose files, and I have this data set. Again, that's the one I linked out to. Again, don't worry, you don't have to download it and follow along exactly. Just really focus on learning how to use this tool so you can bring in a data set after this workshop and train your own model. So I'm going to hit open. It's going to upload here. And as it's uploading, well, you can check and make sure they're all uploading, but we're going to go ahead and go to label definitions. So at this point, this is why, at this point, you want to know kind of what you're doing or how you're going to train your model. So this is where you'd be like, all right, am I going to label for object detection? Am I going to label for feature points? You should probably have some rough idea of what you're going to be doing at this point. So in this case, I'm going to make several examples, right? And you probably wouldn't do it this way for most of your machine learning projects, where I'm going to have one I call Goose, and I'm going to leave it as a rectangle, but this is where you select all the different types of labeling that you can do. We'll come back to that in a second. And I'm going to change this color. This is really just for you as the labeler right now. If I know all my geese are in a green background, I want something that sticks out more. So I'm going to hit like a dark blue. And you'll see this auto label section. I'm going to come back to this, but I'm just going to point out that you can configure the auto label here. And it is what it sounds like. It can automatically label objects. It's really cool. I'll show it off in a minute. But you can configure it here. You can also configure it during the labeling process, which is what we're going to do. So I'm going to hit save now that I've created my object detection label. And I'm going to make another one. I'm going to call it Goose Polygon. And this is where I'm doing this a little differently than I would probably do it most of the time. A lot of times I wouldn't necessarily mix the polygons and rectangles unless you really know what you're doing or how you want to break it out, or you know that that the model architecture or the code you're going to use can break out the differences, which is totally something you can do. It just depends on how you'd want to do it. But in this case, I'm going to have Goose Polygon. I'm going to change the color again to something I can see better in green grass, and I'm going to hit save. And then I'm going to create one for cars. I'm going to call it car. I'm also going to select the polygon here. And I tend to work a lot in polygons, and I'll show you why I hated working in polygons and now why I like it. And I'm going to create one for cups or a cup. Again, I'm just going to go through, this won't take super long, just show you kind of how to use this tool and how to use it on variations of objects and data. I'll hit save. And then I think my last one was just a PCB example of a polygon there too. And I'm just going to hit save. So you type in the name of your label, select the type of label you want. You can also use classification and feature points in here. Today, we're just going to focus on the object detection and polygon piece of things. Now I'm going to scroll down. We're not going to put anything in here, but this is a really useful feature if you're working with teams or if you're working on really complex data that you kind of want to reference instructions as you're labeling it. You can add those instructions here. So, right, like I might be labeling thousands of images and we split this up between 5 people, or I'm paying other people to do it. I can add very precise instructions of how to label right down here. I can even embed images. So even me, right, like if I know kind of what I'm doing labeling or training a model, but I'm not a medical expert or expert in a lot of different domains. So if I was going to label a specific type of tumor or something in medical data, I would still need a doctor to tell me like, what does that look like? And what does a good label for that look like? What does maybe a bad label look like for that? So you can embed these instructions and images in here, which is pretty cool. Again, we're going to leave it blank, but it's really just like a collaborative kind of thing you can do in the tool. So I'm going to hit save and start labeling. And this will bring up our labeling screen. So you can see we have 2 geese. If we wanted to label for object detection, we would select our rectangle label here. And you get this kind of crosshair. I can zoom in and out in my scroll wheel. Also, when I don't have a label selected, I can pan around. And if for whatever reason you get way too lost on your image, you can always hit resize to fit right here, and I'll snap it back to the original position. So if I'm just labeling for object detection, I'm going to select my rectangle, get these crosshairs, and then I want to draw a box around each one of these geese. And you want to be as close as possible of where the goose starts and ends. So like you don't want to have it in like this. That wouldn't help your model. And then you also don't want to be too big, right? Like you want to be very precise. So what's happening is we label where, in this case, a goose is, and then we feed it to our model. It's going to load in this image and it's going to look in these kind of cropped portions. and figure out the features only within these boxes of what make up that object. So here, once you put the labels in, you can also adjust them. So you can come back and adjust this if we messed up at all. And that's kind of how we label for object detection the manual way. So actually pretty fast. And just to note that if you had another goose, or let's say we only labeled one goose, this would really throw off our model. So you always want to label every single instance of that object. Otherwise, your model is going to be very confused because it's going to say, hey, I'm learning the features in here, but then they didn't label this as a goose. So I'm not supposed to be looking for this. And it's just not going to work well if you don't label all these instances. One caveat is like, right, if there's a goose way back here and you were okay with your model not detecting it, then it's probably okay not to label it. But you want to basically label each instance. Someone asked, what if the geese are overlapping? You would still want to do a whole box around it. I don't think I have an overlapping instance in here, but we could probably get to that later. But if this other goose was over here, you would want to draw a whole box around the goose and then a whole box around the other goose. And even if they're overlapping, a lot of the times it tends to work pretty good for picking up the features it's looking for. All right, so let's do polygons next. I'm going to show you a manual way of doing polygons. So let's select this goose polygon. And if you've never labeled for instance segmentation before, you label like this with polygons. I'm gonna go very fast here, so I might do a horrible job, but you want to be as precise as possible, just like with a box, except for you're tracing around the entire object. And you can see like the goose shape here isn't too complex, but if you're doing a really complex object, even with this goose, it's taking me a long time and I'm not even doing that precise of a job, right? So this is why I always hated using polygons unless I really needed to, but like for a hobby project or something like that, I would kind of avoid these just because it's so time consuming to create the labels, right? Versus the bounding box. You saw I just zoop with the bounding box, and this one I have to like spend a lot of time tracing around it. And you probably even want to be more precise in this. So what a really cool feature that we have is called Smart Poly. So you can select our polygon label here. You'll have this little thing called Smart Poly. I'm going to turn it on. I'm going to select it again. And then now we get a bounding box just like our object detection. But now it snaps the polygon to it. So I saw someone say would be nice to have edge detection. So this is doing kind of something like that, but with a trained model that is trained to extract like objects in your square foreground from even a complex background. So I've even been surprised myself sometimes where it's like a really complex background and it works really good extracting the object. So I'm going to do it again on this goose. And with this, you want to be just as precise as if you were labeling for object detection, right? So if I'm way out here, it's not going to have that great of a result. If I'm really tight into where the object is, it'll do a pretty good job applying the label. You can see it's not perfect. It's not always going to be perfect. And if I zoom all the way in, you can see that like my eyes have a hard time telling where the edge of the goose begins and ends. So a Smart Poly is great, even if it's not 100% perfect, because if it gets me like 80% of the way there, I can zoom in, I can go ahead, click this node, I can delete it, I can drag these around. So if it labels basically like 80% of the data for me, and then I just have to do some minor corrections like this, then it still saves me a ton of time for labeling polygons, which is awesome. So Smart Poly, really cool tool. It's definitely changed the way that I use polygons or how much I use polygons, even just in side projects now. And again, try it on your data. It'll work pretty well in a lot of cases. Someone asked, what is pending here? So this little part that says pending, this is saying we have 16 images that are pending labeling. So by default, this loads all the pending stuff. If you need to look at all your images, this is how you navigate to all the different statuses of your images. So right now we only have pending or all images. As soon as we hit submit on this, it'll go and submitted, and then we could go in there and approve it. So if we were going to work as a team, I could have someone label this, then I could navigate to all the submitted images and then approve them or reject them. So let's go ahead, and I'm going to actually just turn on another feature here. So I'm going to go back to this goose rectangle in this case. And this works for rectangles and polygons. Just for this one, I'm going to show rectangles, and then we'll go back to polygons for the next one. So for here, I'm going to turn on auto label. Like I was saying, you could actually turn this on when you're defining the labels, but I'm going to turn it on here. for our goose rectangle, and you get this whole box. And there's 81 classes in here. They're the Cocoa models, or it's the Cocoa model. So there's the 81 Cocoa classes. You can scroll through them all here. Now I know that there isn't one for a goose, unfortunately, but there is one for a bird. So it's cool too, in a lot of the cases with these pre-trained models, right? Like there's not precise one for my goose use case, but there's a bird one that can work pretty well. So I'm going to go ahead and click OK. And it turns on auto label, and it's automatically now applying labels to our images. And I can even go in and adjust it. So if it wasn't perfect, it looked pretty good here, but if it wasn't perfect, I could come in and adjust it. So again, it's like, if it's saving me 80% of the time and I just have to do these minor adjustments, that's huge. So I still have auto label turned on. I'm going to hit submit. So this is now going to throw our image into the submitted bucket down here. So hit submit. And you can see it loaded up the next image and already applied our labels to it. So at this point, if I have a model that works on my data, then I'm really just kind of QAing the AI labeling and fixing any mistakes it makes. So at this point, right, I'm really just like, okay, does this look good? Yes, it does. I'm going to hit submit. And what's really cool about it, so we'll do another example here. I'm going to turn on this car polygon. I'm going to turn on auto label again. So now it's doing auto label, but with polygons. I'm going to select car. I'm going to select truck. Basically, we want to get anything that's going to be on this highway. I know there's one for motorcycles. And what's really cool is coming soon. So I talked about how we're building out that kind of all those computer vision steps in the platform. A lot of labeling today, right, should be done, if possible, by a computer vision model. So after you get started labeling your data, maybe you need hundreds of images, maybe you need thousands of images, depending on what you're doing and how complex it is. Once you have a model that you feel is like fairly accurate, or at least accurate enough to help you, what you can do is you'll be able to train a model in the platform. And then you'll be able to bring that model back into the auto label here. So currently we only have the Cocoa ones in here, but imagine doing this with your own model. It's going to be awesome because Cocoa only works in some instances with those classes. And even with those classes, it doesn't work all the time. Like we'll see an example of that, right? Like there's no perfect computer vision model for all the classes. Most of the time, if you want really high accuracy precision, you need to ingest data from where you're looking at in the field and then train on that data. And then kind of deploy the model. And so this is going to be awesome because it'll work really on any data set that you have. You just start labeling and then your model is going to get good enough. And then hopefully it can do almost all the labeling for you. So I'm going to hit OK here, and it's going to apply the label to my car. And I see there's some questions. I'll try to catch up in a minute. I'm going to get through kind of all this labeling, and then I'll catch up on the questions. But I did see someone ask, how do I bring up auto label? So this little drop down here, right next to your label, it'll be there on both polygons and rectangles. And then you want to click turn it on, and then you can select those different classes. You can also set it up when you're defining the labels as well, if you just want to go ahead and do it at that step. So you can see it put polygons on our car. Again, if I want to adjust them, I can just click on it and I can pull these out. So if it didn't do a good job, I could go in and hopefully it would get me like 80%, 90% of the way there. You can also delete these nodes. So you can see these kind of white outline nodes I can delete by hitting the backspace or delete key while it's highlighted. And then I'll save these grayed out ones. So if this is like, if I need to add more nodes and make a more complex shape, I can. So let me, I don't want that label in there. I'm going to turn on Smart Poly again. I just deleted that one because I messed it up. And all right, so I'm going to hit submit. Auto labels on. Applies the label again. The car moved. Applies the label again. The car moved. And at this point, like I was saying, really, this is how hopefully in the future everyone is labeling their data sets, is you're not really doing the labeling. You're either having a model do it for you and you trust it's good enough, or you're kind of doing a QA on it to make sure it's doing good enough and then adjusting when it's not. So you'll see right here, in this case, because we're using that pre-trained model, it's not used at every angle in our use case here. For whatever reason, it doesn't detect it at this precise location. So I can go in, I have that Smart Poly label, Smart Poly activated, and boom. And I can see another car coming in here. So I'm going to go ahead and apply a label there. Hit submit. And for some reason, again, right, it detects that car, but not this one. Again, there's no perfect model in the world, especially just in a generalized one on the Cocoa class. Hit submit, and then now it's working. And really, I'm just letting it label for me. So I'm going to turn this off, go to this next example, and then we're almost done with these examples, and then I'll catch up on questions and open it up for more questions. All right, so I'm going to do smart poly again for the cups, but I'm also going to enable, instead of auto label, it's in the same spot, this little caret drop down. I'm going to turn on track forward. I'll talk about what that is in a second, but the name might give it away a little bit. So I'm going to enable that. I'm going to now just use smart poly to label these cups. And also, if you're using smart poly and you're not getting super good results, even on the same images, it's probably just you're going too far out. And it's kind of something you get used to if you use it a lot. Again, like you want to be as precise as possible where the object starts and ends. Like if I went a little further out, it probably would capture this shadow there as well. So just noting, it's something like the more you use it, you tend to get just better at using it, which is cool. So I have track forward on. Again, you can enable it here, and then I'm going to hit submit. And what this does is it expects a sequence of frames from a video, right? So these aren't moving super far, and it's not new objects coming in, but this isn't detecting specifically cups or anything either. This is just, it knows I labeled 2 objects in here, and it's trying to understand where they move to in the next frame, even though it doesn't know what type of objects they are. It's just doing automatic object tracking, kind of learning, what was in that box, and then looking for the closest thing in the next frame. So again, this is really cool for videos. And if you don't have a pre-trained model that you can use for the auto label features, this can also save a ton of time just tracking those objects across all your video, all your frames. So I'll turn it off here. Then I have this PCB, but we don't really need to label this. There's nothing new we would really learn from labeling this, but I could label this with like the drawing a polygon around it, or like there's different ways of labeling for this kind of damage. You could do classification. You could have this label as good or bad PCB, or you could have PCB and then have a separate label and then label this damage separately. And then say, if you detect damage inside of a PCB rectangle, send an alert or stop the production line or something like that for the quality assurance kind of analysis. I know some people had talked about it before. So again, if I wanted to navigate to my submitted images, I can do that down here. I can go to all images here. All right, so let's go to this last step, review. Again, we just, like in this case, if I labeled all my images myself, or if you labeled all your images during like for a hobby project or a proof of concept or something, you don't need to go through and approve them. But if you wanted to, you could go hit these submitted, hit approve. Yes, this looks good. Hit approve. You could reject it if it doesn't look good, and they'll go in these different buckets. And then you can export only the approved images if you want. But in this case, I'm kind of saying that this would look like, this would be like, let's say you just did all the labeling right now and you're going to train up your own model after this workshop. So you probably don't want to go through the whole process of approving, even though it's a really important step. And most of the time you'll want to use it if you're in like an enterprise setting. But so let's go to export our data set. So we did all the labeling. You labeled all the data for object detection for whatever your use case is. And then we're going to export our data set. We have a whole bunch of different options. The one we're going to use today is Cocoa, but we also have just our own JSON format that will just kind of work for everything that you can do in here. We also have Apple's versions for classification and object detection, YOLO and Pascal VOC. Most of the time that I've seen in tutorials, people will often use Cocoa or Pascal VOC. I use Cocoa a lot, and one great thing about it is that almost all of those frameworks, like we talked about how they have built-in transfer learning, most of the time they have a built-in function that can import a Cocoa data set. So you don't have to write your own data loader, which can be really annoying sometimes. So like TensorFlow and PyTorch will have a function that makes it really easy to read in a Cocoa data set. So often you'll probably just want to do this if you're using Python to train your model. One very important thing is you want to scroll down right here, because by default, it only exports all the annotations that are approved. And this is because in an enterprise setting, you would probably want to only do approved ones. But we can hit this little box that says submitted annotations as well. So it's just going to do everything that we submitted. And then we have an option here for train and validation and test split. I'll talk more about this when we get into the code and load it in. But essentially, you're using most of your data to train a model, and then you're going to use 2 other testing data sets to make sure it's working as it should. So I'll talk about this when we actually get into the code because we're going to use them. But then I would just hit export now. It says export completed. You're going to get an email with a link that you can download your exported data set. You'll also get a notification right here. So it'll pop up in a few seconds, but I'm going to go ahead and refresh it, and it should be there. Just a push notification. You can click on this, and then you can hit download export. And this will bring you, or it'll download a folder that looks like this. So inside of that folder, you'll have another image folder. So these are all the images that we just annotated. And then you'll have these 3 JSON folders for those 3 different data sets. And again, I'll talk about those in a second. And then don't get scared, but this is what that data set looks like. And again, we're going to use a pre-built function to load this in. So you don't need to know how to read this. But you can kind of see that this is just mapping out those image paths. And it's also mapping out, in this case, we can see that there's 4 for an object. So this is the bounding box locations, right? So this is saying in that image, this is where we draw that box, and then that's what you're going to look at, what the model's going to look at and learn from whatever was in that kind of segmentation or rectangle. So that's all the steps, basically labeling. We saw instant segmentation as well as object detection. I know there's some questions, so I'm going to catch up now on those, as well as just ask, is there any other questions about labeling, anything you want me to cover real quick? And then again, I'll be hanging out after the workshop. So if it's something too long I can't get to here, because we'll want to keep moving to the code, I can help you after the workshop as well. So let me open up for questions and catch up and get a drink of water. Someone asked, is Coco rectangle or polygon? Coco can do both of them. So it's a really good kind of data set type for both object detection and instant segmentation. Someone asked, bring up auto label. I think I might have answered that already, but let me just go back into the labeler. So if I wanted to bring up auto label, I can hit auto label here and then select from those 81 pre-trained classes. And you can select multiple classes here. And then again, soon be able to train your own model on the platform and then bring it right in, which is going to be so awesome. Someone said Smart Poly is awesome. I agree. It's so cool. It's definitely changed the way that I approach labeling. Someone said, can it pick up objects in noisy backgrounds? I've had it work in surprisingly noisy backgrounds, but it will depend on your data. Like, I can't say it works literally on everything, but it works surprisingly well. Someone asked for the link to sign up again. If you didn't get the link, this is to sign up for the tool. I threw it in the chat. You can also go to Plainsight AI and hit sign up in the corner. Someone said, should one denoise before while keeping detail relevant to the subject? I mean, that depends on what you're trying to do with your pipeline. If you denoise before, then that might not work as well with the real world data if it still has all the noise in it. Someone said, can an image have multiple classes of objects? Yeah, so in this case, most of these, I think, only had 1 classes, I guess, so that's a great point. But if we had geese here and if we had a car or a PCB or whatever over here, you could totally have multiple classes. Absolutely. One thing I mentioned, you want to know what you're doing if you're combining different label types like polygons and rectangles, but you could totally have as many classes as you want usually. Someone said, can I sort the images by confidence in the auto label? I don't have the sorting feature in here yet, but some stuff like that is coming. So being able to kind of assess like what's going on with images even before you label it. I think there's a lot of cool work that can be done in that. Someone said somehow they're seeing a blank canvas. The images are not showing. It does say 16 images in the bottom. Did that ever resolve for you? Try refreshing if it didn't. Hope that was a while ago, I think. So hopefully that did not stay that way. Someone said, is it possible to share the labeling task with other users? So right now, you can invite users in from settings to your account if you need to kind of like create a labeling team. Right now, to share it out, though, you can export it. So if you went to export, you can export a data set, and you could do it in the Sense JSON version. And then if they wanted to bring it into their own labeler, they could go back to the homepage and import a data set, and it can import that specific Sense JSON format. Someone said they got the node thing. Rectangle is not a polygon. But how did they get? Oh, okay, I think you're saying you were wondering how to get the nodes and then you didn't have them. Yeah, so just when you're creating your labels, right? If we go to your label definition, you can add the rectangle or polygon here. And I've definitely made the mistake of accidentally selecting one over the other. Or I thought I selected polygon and for whatever reason I didn't. So just verify that you did that. If it didn't, you can come back and actually change that label, especially if you didn't label anything before, it won't cause any problems. There's also a little dashboard. So if you are working as a team where you just want to see your data over time, you can kind of see all the different classes and how many labels happened at what time. So with the, how do I select the source? So selecting the source, you can hit new data set, give it a name, and then go to the sources. Actually, if I go back in, you can upload new data here as well. So you can add a source, and then I just selected a local file for now. All right, so I'm going to keep it moving. I think there's a couple I didn't get to, but let me know after the workshop and I'll get to them. But I just want to make sure that we can finish the coding portion as well by hopefully 7 o'clock or sorry, 7:30 when this is supposed to end in case people have to leave. So let's go ahead and come back here to our slides. Just have a couple. I just want to mention a couple libraries that we're going to be working with, or most of them we've mentioned already, but when you get into the coding portion, right, there's a lot of popular Python libraries for computer vision. There are so many, but the main two for deep learning are the ones we already talked about, PyTorch and TensorFlow and Keras. PyTorch is Facebook's version of this kind of a deep learning framework, and TensorFlow and Keras is the library from Google. They're kind of interchangeable. Like a lot of people will choose one over the other. You have OpenCV, which is an awesome library for image processing and computer vision. And then you have NumPy, which is really great at multi-dimensional array processing, which is what images actually become when we import them into Python. And we'll take a look at that in the code. And then we have Pill and Pillow, which is another cool image processing library. So I'm going to share a couple links here. This is the link to the Google Colab notebook. So you'll want to open this up, share that link, and then I'll share this too. Mention if you want a certificate of completion. I know not everyone cares or wants one, but if you want one, you can fill out this Google form here as well. And it might take me a while to get back to you, but I'll send you one with your name on it. Otherwise, open up that link I shared, and this will bring you to, I'll go ahead and do it myself as well. So this will bring you to a Colab notebook. It will look like this. And then what you want to do is go to File, save a copy in Drive. This is going to make your own copy, and you'll be able to do whatever you want to. You can change the code. So make sure you save a copy in Drive. It's also, if you want, you can bookmark this link, because if you do mess up your own version enough, you can always come back to this one and start from scratch. Because I always encourage to mess around with it and see what happens. Sometimes if you do that, it breaks. So I'm going to give everyone a minute to do that. What did everyone think of labeling, especially if you've never done labeling before? Did it seem like a daunting process? Did it seem not as hard as you thought it was going to be? Someone said it was really easy, especially when you're using the kind of like a tool with these smart features. It definitely makes it way easier. Yeah, so like a lot of people, right, a lot of courses don't really go into the labeling, and it's so important. In fact, right, like we're going to train a model tonight, and there's already so many great computer vision models where you can select one that will fit your data set well. And it really just matters so much more about your data set and the labeling versus training a model sometimes. So there's kind of a movement in the industry right now where they call it like a data-centric computer vision problem or a data-centric machine learning problem, where you're using all these models, like we know they work pretty good, and it's all about creating data or augmenting the current existing data set to like train a model better. So I think it's really interesting. That's a field I'm super interested in. It's just kind of the data set side of things in deep learning, or specifically in computer vision for me, where like you can create synthetic data using different tools. You can augment data in certain ways to create your model better or label better, like just making better labels versus having like a poorly labeled data set makes a huge difference. So I always think it's really interesting that it's often glossed over in a lot of material. All right, just making sure, did some people or whoever want to follow along? I'll share the link again because people are talking, which is great. You should keep talking, not saying don't. I'm just going to share the link again for anyone to open up this Colab notebook and make your own copy, save a copy in Drive. Did anyone do that yet? Someone said they want a mechanical Turk integration. If you are looking for outsourced labeling, we can do that in there. So I think there's even a thing here is labeling services. So if you are interested in a similar thing, you can hit labeling services if that's what you're looking for. Someone said they definitely more powerful than the open source package. Yeah, so the what is it? Label image, or yeah, I think label image. I always get it backwards if it's image label or label image. Yeah, so like you can label like the bounding boxes, and I think you can manually draw the polygons, but it takes so much longer. And even the UI, from my memory, unless they've changed a lot, just it's great having an awesome labeling tool, let me tell you, especially if you're going to spend a lot of time labeling. Right, so just again, go to File, save a copy in Drive. I'm going to go ahead and do that, make my own copy here. Someone said, when they make a collab, can you share it with certain people and only them have access to it, or whoever knows the link has access? I believe if you go to sharing, it's very similar to like any Google Doc. So if you want to change those settings on your own copy, you're more than welcome to do that. All right, so this is Google Colab, and this is essentially Google's way of hosting what's called a Jupyter Notebook. If you've never used a Jupyter Notebook before, it's a really popular tool used in data science and machine learning. It allows you to write code, documentation, and output visuals all in one place. So it's really great for like experimenting and documenting what's going on. And kind of like, you can even train models and stuff in here, and then like save the model out and then use just code without a Jupyter Notebook to kind of serve up that model. But you might want to use something like a Jupyter Notebook to look at the output of it and kind of do those adjustments. So really cool tool. And then Google Colab has some really great stuff where you don't need to do this because you cloned it from mine, so it's already set this way. But you can hit change runtime type, and they actually give you a really good amount of free GPU and TPU time. So if you're training deep learning models, you usually need a GPU. A lot of people don't have one or a good one. And it's awesome that Google gives you a good amount of free time that you can really just get started with deep learning, even if you don't have one. So it's a really cool feature. And then you can double click on a text cell. It'll bring up this markdown view. And then to get out of it, you can hit Shift Enter. To run a code cell, so this is a code cell here, you can hit this little play button, or if you're on the code cell, you can hit Shift Enter. So most of the time I hit Shift Enter, and so you won't see me clicking the play button, and that's me hitting Shift Enter, and we're going to run this code cell. Once it connects to an instance here, it will go ahead and run. So we can see it printed out hello world. Someone said, is there a link to this? Yep. If you missed it, or if anyone asks for the link later, if someone wants to keep track of it and share it, that'd be cool. But there's the link for the notebook. Just hit save a copy in Drive, and you did not miss much yet. All right, so we ran a piece of code here, and if you've never done Python before, congratulations, you did now programmed in Python, so you can add it to your LinkedIn skills. Just noting too, in Google Colab, it's not just a Jupyter notebook, it's really running like a whole instance of Ubuntu back here, so you can use bash commands, which again, if you don't know them, don't worry. ls is just really listing all the items in the directory. So we can see there's a folder called sample data right now. And then we can pip install different libraries as well. So Colab comes pre-installed with all the major frameworks like scikit-learn, TensorFlow, PyTorch, and I'm going to go ahead and run this cell. What we're doing is we're pip installing a specific version of PyTorch. What happens in Colab is they always put pretty much the latest version out, and sometimes it can mess with your code because if you wrote everything expecting to use PyTorch 1.8 and then 1.9 is now the newest or 1.10 is now the newest, they'll throw it in here and it might break your code. So I had this in here when it was still 1.8. And I didn't really, if I ran this, it just said, hey, like this, all the requirements are already satisfied. But now that they changed it, it's going to take a minute just to install the correct version of PyTorch. So it's a really good idea too, if you are making a notebook and you want it to kind of last, or you want to share with people and you don't want them to run into any issues, is to actually make sure you're installing the correct version of the libraries that you built your tool with, because otherwise it might run into an error later. So all we're doing is installing a slightly older version of PyTorch just because I didn't update this code to work with the newer one. And it should just take a minute. Is this running for everyone? Someone said yes, awesome. Then if you're running all the code and everything's going pretty smooth, then you should hopefully be good for the rest of this workshop. This is like one of the longer code cells, I think, because it has to uninstall. You can see it's uninstalling PyTorch 1.9. I should just rewrite this notebook for 1.9 and this will go a little bit faster. But yeah, I had this in here just because I knew they were going to upgrade at some point, and then I didn't want to break everything like 15 minutes or if it broke during the workshop and I didn't know it, that would be pretty bad. So I always like, if I'm doing Colab notebooks for sharing out like this, I always have one to install the correct version. But it is taking a minute. And it always feels way longer. I don't know about you all at the workshop, but when when I'm presenting, like I feel like it's like 30 seconds feels like it's like 5 minutes. So hopefully we'll be done soon. No, we don't use torch text. So if you get any of these errors, don't worry about it because we're not actually using it. So we updated this version of PyTorch and Torch Vision, and it says it's not compatible with the version of Torch Text. We're not using that. You can use that for like NLP applications, but we're not using it today. So go ahead and run the next cell. This initial setup part can take a little bit just because now we're installing some of their libraries. We're installing something called PyCoco tools to work with the Coco dataset and PyYAML. And this is just I had these to verify that we have the correct versions installed because we can see that this version of Detectron 2 requires PyTorch 1.8. So go ahead and run this. Once we get after all this installation stuff, it should be more fun. But it's important. Yeah, that's like the one almost like downside of Colab is just that like it's a cool thing they automatically have stuff installed, but it's also you can't maintain an environment unless you kind of install this every time. So right, like you wouldn't want to use this all the time maybe versus local development if you don't want to have to install these packages or manage what's there all the time. So go ahead and run this. Again, don't worry about any of these errors. Everything should be fine. Sometimes it says you must restart the runtime. I think we're going to be okay. So I've run this before. Don't worry about any of those about restarting runtime or anything unless I tell you, which hopefully you shouldn't run into any of that at all. All right, now we're going to import. So we installed Detectron 2 and these other libraries. We're going to import them in. If you've never programmed in Python before, this is how you import a library into your project. So you can download those to your computer, or in this case, to our Colab instance. And now we're pulling them into our code, telling Python, hey, we're going to use these things. And we'll talk about these a little bit as we use them. But these are really just certain things from Detectron 2, like model zoo. We'll see what that is. That's where we can select different models from, and some different configuration stuff and visualizer helpers. So go ahead and run this. And if this works for you, then hopefully everything else should be really smooth because we installed all the correct things. If you do get an error anywhere in here at any point in the notebook, most likely it's because you accidentally skipped a cell. And you can always come in here, hit runtime, and you can actually hit run all, or you can restart the runtime, or factory reset the runtime. So let's get rid of everything we installed, and then you can hit run all, and then it will run them all in the correct sequence. So if we're like further down to the workshop and something happens and you don't know where, and I can't troubleshoot it with you at this moment, go ahead and hit that factory reset runtime, and then just hit run all, and it'll run all the code cells, and you should be able to catch back up. All right, so talked about labeling. We already did this, so don't worry. I just have a link out if you want to sign up if you weren't already in there. All right, okay, so downloading our already labeled data set. So we saw how to do all the labeling in that tool, and now you know how to label for object detection or segmentation, and then how to export that data set. Now, how would you get that into Google Colab? So you could do it on your local machine, but I'm going to talk about how to do it on Colab, just assuming not everyone has a GPU, and you could literally take this Colab, swap out your own data set, and train a really cool model on it. So there's a couple ways of doing this. For this workshop, we're just going to run this code cell. This actually is just going to download a data set I already labeled for you for geese. And it's on GitHub. And I wouldn't recommend necessarily doing this for all of your data. This just makes it really easy for us to do it in a workshop so everyone can get the same data set. And if I list directory, I can see there's my image folder and those 3 different JSON files. And I can look in that image folder, and I can see here's all my, I think it was 143 images. And then a lot of those images contain more than one goose. So there's quite a few instances of them. So this is how we're doing in the workshop, but just want to note how we would do this. If you label your own data set, you export it from our platform, and then you want to bring it in here, there's a couple different ways of doing it. So one, if you run this code cell, it's going to go ahead and register the data set we downloaded. But let's talk about if we want to change this settings out to your own data set. And we won't actually do it right now, but I'm just going to mention a couple different ways. So if I open this folder icon here, it's going to bring up this little file explorer. And you can see this is our data set folder here. We can see the all the different data that's in it. And then what we could do, one way to bring data up is we could look in our Finder here, or whatever your computer calls it, the like file explorer, and then select those images you want, or select that whole folder, right, that you exported. And then you can just click and drag it up in here, and it'll upload into your instance like a folder like this. And then you would want to get your new train.json, copy path here, and then you could just paste that new path in here. So this file explorer is really cool. You can find where things are. And this is really just, we're telling it to look at our data set, look at our JSON file. And then one very important note, though, when you're copying a new path to the data set for these, like this is to the JSON file, and this is to where the images live. But if you remember, when we looked at our JSON file, the IMG folder was part of the path. So it's tempting to say, cool, all my images live here. Let me copy the path and then paste this in, and you'll get that /IMG at the end. But you want to remove that because that /IMG is actually part of the Cocoa path. So it can seem really confusing, but once you do it once, it's very easy, and hopefully we won't run into any issues after that. But I'm going to mention another way, and you don't have to do this right now because it adds a layer of complexity. So probably don't click on this, but you can hit Mount Drive. This will mount to your Google Drive. If you're doing it for the first time, it's going to ask you some extra permission stuff. So that's why I don't recommend you doing it now. But you can mount a Colab to your Google Drive, and once it's done mounting, let's see, it'll show up. You now get access to your whole Google Drive, and then you can save a data set in here, and then do the same thing. So And the reason why you'd want to do that over just dragging it up and uploading into the instance is this instance will disappear when it disconnects. So like I was saying, you get a certain amount of GPU time. I think their uptime is something like 12 hours, but it's very easy to get disconnected or have like you walk away, get disconnected, and you have to restart this whole instance. All the data you uploaded is going to be gone. So if you're trying to label or train a model on thousands of images, it can take a long time to upload each time. So I wouldn't recommend it. What I recommend doing is mount to Google Drive and then have a permanent folder, like just go to your Google Drive outside of here, upload your data set there, and then point your model at where it lives. So you can then, again, navigate your drive here, just right click, get that path, and then paste it in here. So again, sorry, it sounds a little complicated. Once you do it once or twice, it really is not that bad. And so I would just recommend looking at the Google Drive way if you're going to do kind of more a permanent data set and maybe plan on experimenting it for several days versus just one time. So I'm going to exit out of that for now, but just want to mention that. Yeah, someone said could not fetch drive content G drive. So that's probably like I was saying, if you ran that right now, you have to do some other permission stuff to it, I think. So don't worry about it right now. But if you hit it and you haven't done it before, it inserts a code cell and it'll say like you have to go to a path and get like a key it generated for you and then paste it in. But for this workshop, don't worry, you don't need to do it. That's what I was saying. Don't even click on it right now. I just want to mention when you're doing your own project, you might want to do it like that. But let's go ahead and run this code cell. This is registering 3 different data sets, our training data set, our validation data set, and our test data set. We point to all those 3 different JSON files that were in our export that we saw previously. This code cell here is just loading in 3 random images. So once you register a data set, it's always very important to make sure it read them in as you thought it should be reading them in. So in this case, we're using a Cocoa data set and a Cocoa data set reading function. So we would assume everything is probably going to be okay. But especially if you are doing your own data loaders or anything like that, you'll want to make sure that, hey, my function is reading in the images and reading in the coordinates correctly. So I've accidentally done this before where I built my own data loader for something and I messed up the X and Y coordinates of my bounding boxes. So instead of drawing it over the goose here, it was like drawing it down here. And my model learned nothing. And I was like, why is my model not learning? And then I went back and looked at how I read in my data set because I didn't check it because I was so full of myself and it was wrong. So then I had to fix it. So ever since then, I always read in my data set, I always verify that it's loading correctly and that it's drawing the coordinates of my labels correctly. And I always suggest you should always do this as well. So we can see here, loaded the images and the coordinates of the boxes look correct because they're drawing around a goose. We can look at our dataset dictionary. So once we read it in, right, this looks similar to that JSON we saw before. It's just now it's a very large Python dictionary. And you can see it's pointing to specific images. And it has different like IDs, it has metadata about the height and width of them. And then also it has the annotation data, which in this case is just bounding boxes, right? Drawing those coordinates of the rectangle. So there should be 4 per object in there that draws a rectangle. Right, so I'm gonna go ahead and run this code cell. This is actually interesting because one thing that's not super cool about Detectron 2 is it doesn't have a easy pre-built way of doing validation while you're training. I'll talk more about that in a second, but I took this from this blog post there that made it very easy to do that. Because when you're, well, let's go ahead and start training our model because that can take a little bit and then I'll dive deeper into everything that's here. So go ahead and run this cell as well. We're gonna make sure our model starts training and then I'm gonna talk about what's going on. All right, so we're getting some data. It read in my images. There's 260 instances of geese. It's downloading the model we pointed at from the model zoo. We'll talk about that in a second. And I'm going to trust it's going to start training. So let's go back up here. So the train, validation, and test split, what's happening there is we had 80% of our data for training. We're saving 10% to do data validation and then 10% for testing. Data validation is where while our model is training, basically, we can look at like how accurate the model is getting and its loss function. Typically, you want loss to go down and accuracy to go up while you're training a model. And almost all the time, it will do that on the training data set because it's learning from it and it can overfit on that data. So it can become really good at detecting geese in the training data, but it might not detect geese in other situations or in the other images that we have that it didn't specifically train on. So what we do is with the validation data set, while the model's training, we're going to say every 50 epochs. So it's going to look at the data 50 times. And then we're going to say, all right, you've learned from all the images 50 times. How well are you doing on images you've never seen before? So we're going to load in that 10% validation data set after 50 cycles and then see how well it's doing. So it's actually kind of a better data point to see how your model is working, because again, like I was saying, it'll almost always go up, or accuracy will almost always go up on the training data, but you want to make sure it's generalizing well on data it's never seen before. That'll give you a better idea if it's actually going to work on real world data or not. And then you have your test data set that, so as you're looking at this validation data set, you might go, oh, it's not working well at all. I want to adjust some hyperparameters. Like I need more data. I need to look at the data way more times than 300 cycles. I need to look at it, 1,000 times, or I need to adjust my learning rate or anything like that. After you adjust all those things and it seems to be working well on your validation data set, then you want to test your model on a separate test data set. So because you were tweaking things while looking at the validation, you never want to really evaluate your model on stuff that helped you make changes during training. So then you have a separate test data set that you can use after you're kind of done training your model and you think it's going to be good. Then you have a separate test data set. So that's kind of the whole thing of like the training, the testing, and validation split. All right, so I'm going to walk through what's going on in this configuration for setting up Detectron 2, and I'll also show you what to change for your own data set. So first, this is kind of the method you use to set up the trainer for Detectron 2. You have this like config module, and then we're going to say merge from file and then model zoo. So this is pointing out what type of model we want to train. And you can go to the model zoo here. So I don't think I need to share all these links in chat because hopefully you're in the notebook or you saved a link to the notebook. But you can look at all the different models available in Detectron 2 over there, and you can use any of those kind of in a notebook. And what we're doing here is we're selecting the faster RCNN version for object detection. If you wanted to do instant segmentation, you could look at the model zoo, find a different instant segmentation one, or you could just copy this one I have up here. So if you wanted to do instant segmentation versus object detection, you would just change this path out here with this one up here, and you want to change this one below it too. This one below it is getting remember when I talked about transfer learning, how you have pre-trained weights? That's what's happening here. I think all these models, or most of them, have pre-trained weights for transfer learning. So we're going to say, hey, get this checkpoint from the same path that you chose up here. So this should always be the same. These two should always be the same. So if you're going to change it for instant segmentation, change both of these. So you can use transfer learning for any model that you choose. And then here, this is an important variable you'll probably want to change. Right now, we're just looking for one type of class. We're just looking for geese, right? So there was only a goose label. But if you had a goose and duck, if they were two separate labels, you would change this to 2. If you had goose, duck, and boat, that would be 3. So remember to change change this number to how many classes are in your data set. And then this is our training data set. So you can pass multiple ones in. If you scroll all the way up, we can see that we created my dataset train over here when we registered our Cocoa instances. And then you have a learning rate. We won't really get, we have the max iteration. So this is how many times your model is going to look at the data set. So we're only using 300 tonight, and we'll see it won't take that long to run. But if you have more complex objects or more different classes, you might want to choose way more than 300. Maybe it'll be 1,000, maybe it'll be 1,500. But you can go ahead and change this number here to look at your data for a different amount of cycles. Then you have learning rate. We won't really get into this here, but this is kind of adjusts the way your model can learn. So you can kind of look up how to adjust this, but you might want to go up or down. And then you have some advanced things that we don't really need to worry about here, but like you can do different numbers of GPUs and different numbers of images per batch. So basically, when we're training a model, it reads in a certain amount of images per batch and a certain amount of annotations per image. So these are all kind of advanced things. You don't really need to worry about them, but you can read the Detectron 2 documentation, which is linked up here if you want to learn more about those things, but you don't need to know about them. All right, so, and then this is where we created that evaluation class, and we're saying every 50 cycles, run the model on the validation and see how well it's doing. So we scroll down, we're going to see a lot of output over here. And we can see this is kind of the output of the, this is the output of the model training. And the most important thing we'll want to look at right here, or this is the output as a model trained. So you can see the loss is going to go down, and some other data reported here. But the most important thing that you want to look at is how well it's doing on that validation data set. So let's actually look at the first one. So it loaded in our validation data set. There was 37 geese in there. We can see after 50 cycles, the average precision, which is, I'll link to an article later in here that goes way more into these metrics for object detection, but it's really hard, right? If you're doing a classification algorithm, it's much easier to know if you're wrong. If it was just, is this a dog or a cat? That's like yes or no. If you're doing object detection, you want to measure kind of like the area of the bounding box, right? Because the bounding box could be around the object, but maybe it was really big, or maybe it's over part of the object, but not all of it. And so there's different ways of measuring that. And I have a good article that talks about all these different metrics and how to think about that. But basically, you just want this number to go up, average precision, and you have different variations of calculating the average precision. So you can see right now, we are at 36, and we would hope this goes to a much higher number. And after 100, it's all the way up to 72. So it had a big jump in learning, right? It was 36, and then after 100 times, we're at 72, and then we're at 78, so it's still learning. And we end around 80-ish average precision, I believe, on there. So really, we can see that our model learned basic, right? Like every 50 cycles, we ran our model on a validation data set, and it was learning how to work. It's picking up the right features of detecting a geese, even not just on our training data. So let's go ahead and run this. That will bring up TensorBoard. Occasionally people say this doesn't load for them, but TensorBoard is a cool way of kind of exploring all the output of your model. So we got some during training here, right? But maybe you want kind of a graphical representation of it, or to kind of see how it did over time, besides scrolling through all this crazy text. So we can see the average precision over time, right? It was going up, and then it went down a little bit here. So maybe we're overfitting our model now. Maybe we want to pull it back, and maybe this is going to be the top performing spot. So we could stop training then, or use that version of the checkpoint potentially. Or maybe if we kept training, it would go back up. And you can explore things like the loss, like it should be going down, and things like accuracy over time and stuff like that. So a cool way of kind of visually exploring all of your data. Oh, someone said it seems like it's doing faster for you, still doing training for me. Great observation. So the one thing about Google Colab as well is you don't know what GPU you're getting. So it's awesome because they give you a free GPU, but sometimes they give you a lower grade one, or sometimes they give you a higher grade one. So some people will say, like some people, you might not be done training yet, and it could take like 1 more minute. It might take 10 more minutes. I'm going to keep going just and talk about all the next code cells. So you can just keep running all the cells after you're done training to catch up. Someone said, is TensorBoard used after training or during training? So in this case, we're just loading it after training, but you can definitely use it while training, which is cool. So if you want to, I don't know if you can do it in Colab, because I think you can only execute one code cell at a time. But if you're doing it on your local machine, you can bring up TensorBoard while your model's training and look at those checkpoints. So that's a great point. It's actually really cool to use it while training. I just don't think you can do it in Colab the way that they execute. Oh yeah, and so I do have Colab Pro, which I think it gives me a little higher priority for higher grade GPUs versus the free ones. And I don't remember all the details. They even have another tier now that's like Colab Pro Plus or something. But basically, you just get more uptime, and you'll be more likely to get a better GPU. But the free one is great. Like the free one, you really don't need to upgrade to Pro unless you use it a lot. All right, so I'm going to keep going. I see some questions, but I just want to make sure we finish this pretty soon. And again, I'll be hanging out after the workshop as well. But let's go through the rest of the code, and I'll try to catch up on these questions, or you can ask them again if I don't get to them. So if we look at our list directory for output, this is what was made. We have our model final.pth, which is the PyTorch extension for a model. So to load in our model now to use it, we're going to use this kind of configuration method again. We're going to say config, get config, and this should be the exact same model that you chose before as well. So again, if you changed it to instant segmentation, you want to change it here. But you'll notice the big difference is we're not loading pre-trained weights anymore because we're not using transfer learning. We've already trained a model. Now we want to load in our own model. So if you wanted, you could also save this model to your Google Drive and then navigate to where it is, copy path, and change that path out here. But we don't need to do that because it's already in here. So it's just in the contents output model final.pth. And we're going to load in our test data set because we're going to use it in a minute. Now that we've looked at our model, saw the validation going up, feel pretty confident with it, then we can now do it on our holdout test data set. And then here, we would want to change this again. If your data set had 2 different classes, this would be 2 instead of 1. And then this is important as well. So this is saying only draw out the prediction if you're this confident that it's this object. So in this case, we trained for geese. This is me saying only make a prediction that it's a goose if you're 90% or higher that it's a goose. Otherwise, don't draw out a prediction. And you might want to adjust this down, especially if you have a much more complex object and your model isn't as confident about it. It won't draw any predictions unless it's 90% sure here. So you could change this to 7, it could be 70%. So if you train this with your own data set and you come in here and you get to this point and the visualizations aren't being drawn out, maybe you lower this number down because your model might not be as confident as this one is. And if you make it too low, you'll notice it draws a whole bunch of different boxes. Like if we said only 10%, it might draw everything as a goose. And if we want, we could look at this later too. So I'm going to run this, and then we're going to make a predictor variable function here that we can use to pass in an image and then get those predictions returned. So here I'm saying test image path, and I'm passing it to an image from our test data set. So the model's never seen this image before. We're loading it in with OpenCV. And then we're going to get the outputs, which is going to be our model with that image passed in. It's going to provide some outputs. And then we're going to use this visualizer function that we imported from Detectron 2. And we're going to scale it down. And we're just going to draw this image out. So go ahead and run this. And did it not draw for the other one? Interesting. Maybe our detector isn't as good here. Or maybe it's overfit on it. I've done this before and it's been fine, but so actually maybe it's not as confident. So let's actually lower this down to 70 and see what happens, right? Yeah, so that one is 89% confident it's a goose. It wasn't 90%. So if you ran this and you had both, that totally could be true, because models, even though we have the same data set and all the same settings, they all learn a little bit differently. And that's just how the deep learning models tend to learn with like stochastic gradient descent. There's a little bit of variation that happens there. So they're probably going to be close, but they might not be perfect. And it's funny because mine was just 1% away from being written out, right? So I'm actually going to go back, just change this to 80. But that's a good illustration of what I was saying, right? Like if your model isn't writing these visualizations out, you might want to lower the confidence threshold here. So here it's returning geese, and you can see the 0 in the beginning. That's class 0. So Python, like most programming languages, starts with an index of 0. So it knows that, hey, I'm predicting a 0 and I'm 99% or 89% confident that this is class 0, which in this case is a goose. So again, if you ran this and you got a prediction, congratulations, especially if you've never trained a computer vision model before, because you now know how to label the data, train a model with your own data, and then run it on an image. And we'll run this on a video in a second as well. But give yourself a round of applause, because that's really hard. Like, that's a really complex thing to do, is create a data set and train a model with it and then run it on an image. So if you've never done this before, hopefully it's a cool feeling to actually see you've trained a model and you can actually use it now, which is really cool. Remember when I said images are multi-dimensional arrays? This is actually what the image looks like when we read it into Python. It's truncated here, but you can see this is really just color values for the pixels, red, green, blue. I'm just showing that for fun there. And now I just want to print out what those outputs actually are. So here we're writing them to an image, but the outputs actually that we get, and sometimes this is really more important than the cool visualization, right? Because yeah, the visualizations look awesome to us as a human, but if we're making a decision with like another algorithm, once we get these predictions returned, we really often just want this data, right? So these are the coordinates for those bounding boxes. And based on these coordinates, we could even say that, hey, these geese are overlapping. Like maybe they're too close together for if we're monitoring social distancing and we know how the camera's angled. So if they were overlapping, we knew they were close to each other or something. And then we know there's two instances, or we could calculate that there's two instances of 0 predicted, which in this case would be goose. So if we were building something, right, saying like, hey, only text me if 2 geese are in the image, or more than 1 goose or something like that, you can take all this data that's actually returned from the output from your model and then do something with it, which is really cool. And just noting real quick here, so you see this 2 CPU, this is common to see in PyTorch. What you do is you move things, like if you're doing predictions or training a model, you're doing that on your GPU, because you usually want to run a model on a GPU. And then once you do that, you want to move that data off of the GPU to a CPU to do kind of the rest of the processes. So if you see anything like 2 CPU or 2 device in PyTorch, that's what's happening there. So let's go ahead and, in this case, it actually creates a little thing, right? It just does the count. We're just saying, hey, how many geese are in here? Detected 2 geese. Let's go ahead and run this on another image. And you can see even here, it works good. Detecting these 3 geese in my living room. There's actually a story. I think I have a link to it in the notebook somewhere, maybe at the end, but there's a story behind this data set and why there's geese in my living room. I mean, it has to do with kind of the data-centric thing we were talking about and creating synthetic data sets. I can talk about that more. I can talk about that more later as well. Real quick, evaluation metrics. So we can go ahead and run this code cell. And this is actually just going to load in our separate test data set that we did not look at yet. And then we're going to see how well our model's working on that data set now. And so this is the link I was talking about that actually does a really great job about talking about how those metrics work, right? Like measuring the intersection over union and seeing like how to measure bounding boxes, because it's much more complicated than like you would just do for classification. So we're going to see in our test data set that we never looked at all before, not even during training, we're still average precision of 72, and the other kind of different variations that we'll calculate. And then, all right, real quick, just kind of the last part of the code here. We're on our last stretch because it is 7:30. So I want to make sure anyone who's still here can get through. Go ahead and run this code cell. What this is going to do is just load in this YouTube video of mine, and it just shows some geese walking around. And then now we're going to take this video, and then we're going to run our model on it and then write out a new video with our detections drawn. So we're going to pip install another library. If I didn't mention before, pip install is a way where you install Python libraries with Python. And this is called YouTube DL for YouTube download. And then you actually don't need to run this code cell for this workshop, but sorry, this one you do need to run. The next one you don't need to run. So here it downloaded my YouTube video, or it's downloading my YouTube video. If I run this next code cell, this is actually just going to take that YouTube video and make a very short clip out of it. Oh man, I don't know why it's taking so long today. Normally this goes really fast, but it says an ETA of 1 whole minute. Like I was saying, when I'm presenting too, it's like one minute feels like 10 minutes. I guess maybe the YouTube servers are slow today. Is anyone else at this point, and did it go fast? So it's slightly faster. Everyone might have slight variations in kind of the time of everything as well. Almost done. Someone said they caught up now. The training was slow. Yeah, sorry about that. It'll vary on the GPUs you get, especially in the free version. Even the pro one, it varies. Almost done. One. All right, I got my video. Now, we don't have to run this for this workshop, but I just wanted to show that you can create a clip out of this. I use this sometimes if I'm doing like a video and it's a minute long, it can actually take quite a bit of time to run the model in each frame of that video and write it back out. So sometimes I like to test it with a shorter clip. So this created a 6-second clip from our video using FFmpeg. And then if you wanted to, you could go back to our Content Explorer, find that clip and copy the path and then paste it here. But since our video is so short today, we don't even need to do that. But I just want to mention, if you're doing this on your own video and it's a lot longer and then you get frustrated, you waited a lot of time and it was wrong, you could do a test clip first. So go ahead and run this code cell and I'll talk about what's going on as it's running because it can take a little bit to run. And I'm going to go ahead and run the next code cell just so when this is done, it will go ahead and start downloading because that can take a few minutes too. And while that's going, I'm going to share these links in the chat since we're near the end here, but then I'll talk about this code cell. So these are all the links of like sign up. If you want to stay connected on LinkedIn, Twitter, GitHub, you can find our Medium. It should reroute you to Plainsight. It didn't change this. I should have. And then this actually is the link to the talk about how this data set was created, why there's some synthetic data going on in there. And of course, the link to the Slack if you want to stay connected. But all right, back to the code cell that's running. So we're importing again, video visualizer, or I think last time we only used visualizer, which was for images. Video visualizer is similar where it'll easily draw out those like rectangles for us. And here we're getting some metadata from our video. So while we're passing in one to capture, we're saying, hey, we want that video we just downloaded as video.mp4, which was my goose video, getting some metadata like the width and height, the frame per second, the total number of frames. And then we're making a variable called video writer, and we're using the video writer function from OpenCV. We're going to write it out as out.mp4 as an MP4 format. And really, we're just saying we want the same number of frames per second. So we're not creating the video and making a worse video. We're essentially reading all those frames, writing them out the same as we read them in. And then we're going to pass in our test data set here. This is really just to get like the class goose here. Really, the only metadata we're getting from that is that. So instead of writing out 0 in the confidence level, it should write out goose in the confidence level. And then here we have a function called run on video. We're passing in the video. We're saying the max frames. And really, this is just saying, well, while there's still frames left in the video, just go through this loop until you've gone through all the frames. And we're getting frame from the video. We're passing our predictor just like we did on the single images, but on each frame. And then we're writing out that frame. Oh, by the way, so OpenCV reads in images the reverse color order than most other libraries. So most of the time, right, you have red, green, blue, but OpenCV expects them in blue, green, red order. So you often have to reverse the colors once you read them in. And then we have our visualization. We're just using that visualization function from the video visualizer from Detectron 2, just to draw out those rectangles, just like we did for the images, but now we're doing a video. And then we are writing that back out. We're yielding that visualization out of the while loop. And then we're just stitching it together down here with the video visualizer. TQDM is a really cool library that allows us to kind of get this output saying the percentage that we've gone through, which is kind of cool. And then we're just kind of closing out OpenCV down here. And then now we're downloading. And did anyone's video download yet? Mine is still downloading. So I know everyone else is probably still downloading as well. All right, I'm almost there. Someone asked, under the hood, is the model we use was a CNN model? So yeah, it will use a convolutional layers for part of it. If you actually look back at the output when we trained it, I believe it uses ResNet 50. I could be wrong, but there's more to just like ResNet 50 is used for classification, which is used as part of the backbone for the object detection algorithm. So there's convolutional layers in the backend. I think it's your question. So yes, but then also more. All right, I got my download. I'm going to open this up and we can see that it wrote out the visualizations on our video. And it's doing pretty good. Especially for like not a ton of data, right? You can see, I guess, the head's out a little bit there. We could probably train for longer, or we were started overfitting or something, or again, right? We also didn't have that much data. If we had a lot more data, it would probably be even more accurate. And maybe the data variation didn't quite have this kind of lighting as well, right? Like I think a lot of the images I had are better contrast for like the geese and grass, and here it's not quite as good. All right, so I'm going to share these links in the chat again. That's all part of the code, but I will be hanging out and answering questions. But I'm going to stop the recording, and hopefully y'all learned something really cool. Again, going from start to finish of learning how to label your own object detection data sets, and then training a model with it, and then using that model on images and videos. And hopefully you had a really great time. And again, I'll be hanging out, but I'm just going to stop the recording.